Hello, grade 11s. We're going to try doing some videos on my iPad, so just bear with me here as we go through it. It might be a little messy, but I'm going to try my best. Remember to please be writing down your notes either on your printed out handout or on loose leaf, but it does help you process it to write it out. So the first section 6.1, this is all about rational expressions and rational functions. Section 6.1 is just focusing on the simplifying. So let's take a look at this. A rational expression is an algebraic fraction. That should be your key word. This is a fraction of the form p over q, where p and q are both polynomials and q cannot equal 0. So that means the denominator can't be 0. Now, non-permissible values are something you're going to hear lots about, but this is when the denominator does equal 0. So here I've got a little example where you'd have x plus 2 on the top and x minus 3 on the bottom. Notice they're both polynomials, but the bottom cannot equal positive 3. If it does, 3 minus 3 would equal 0, and we can't have 0 in the denominator. So we would say that the non-permissible value, which you'll see I always write NPV, is positive 3. Now let's take a look at another one with non-permissible values. So for each one, we're going to determine the non-permissible values. For question A, I see that there's an s and an r squared on the bottom. So s cannot equal 0 and r cannot equal 0. So those would be our two non-permissible values. That s would be 0 or r would be 0 are not permissible. Then let's look to B. Here I have in the denominator an x and a 2x minus 3. So that means that x cannot equal 0, or it would be non-permissible. But when it's a little bit bigger one, like 2x minus 3, what we do is we set it equal to 0 and then solve it. So I'd add the 3 over, so we get 2x equals 3, and then divide out the 2, so x equals 3 over 2. Now again, x can't equal 3 over 2, so I usually just put a little line through the equal sign. So those would be my non-permissible values. X cannot equal 0 or x cannot equal 3 over 2. Now in one like C, the bottom needs to be factored. So we need to factor p squared minus p minus 12 by looking at what two numbers add to get to negative 1 and what two numbers multiply to get to negative 12. So that would be negative 4 and positive 3. So again, when I factor this, I'd get p minus 4 and p plus 3 in the denominator. So that tells me that p cannot equal 4 or p cannot equal negative 3. Because if you plugged in a 4 for the p, 4 minus 4 would be 0. And if you plugged in a negative 3 for this p, negative 3 plus 3 would be 0. So those two values are non-permissible. Remember to pause the video at any time. If you feel like I'm getting ahead of you, just take a second to finish your copying. Okay, next we're going to get into simplifying. So to simplify, you have to divide both the numerator and the denominator by any factors that are common. So we just divide out anything common. Now think about this with fractions. If we have 9 over 12, I know that 3 goes into them both. So I would divide out a 3 from the top and the bottom, which reduces it to 3 over 4. So that is the exact same way that we reduce fractions. We divide out common factors. Let's look at one more complicated though. This one's m cubed t and m squared t to the power 4. So if I just look at the m's, I would have an m squared that's common. So if I divide out an m squared, there'd be none left on the bottom, and there'd be 1 left on the top. Then I'm going to look at my t's. So here this would be t to the power of 1 on top and t to the power 4 on the bottom, so there'd be 1 that's common. So I'm going to divide out the t to the power 1, which would leave me with 3 t's on the bottom. So t cubed. So this one, when you reduce it, you're left with m on the top and t cubed on the bottom, and now there's nothing else that can be divided. All right, so for example 2, we're going to simplify these more complicated rational expressions. And on the side here, I just put a few little steps that you should go through. So first, you always factor everything fully. Step 2, you're going to state the non-permissible values. And then step 3 is you divide out anything common, which actually looks like canceling. So let's look at A. On the top here, I see that 3 goes into both 3 and 6 in the numerator. So I'm going to factor out a 3. and I'm left with x minus 2. In the denominator, you're going to need to factor this either using the box method or decomposition. So remember that you'd start by going, okay, what two numbers add to get to positive 1, and two numbers multiply to get to negative 20. And those two numbers would be 5 and minus 4. But you can't just put those in because there's a front number, so you actually have to go through your box or decomp. So I'll just quickly review the box method. We'd have our 2x squared in the front, our minus 10 in the back, our 5x and our minus 4x in the other two boxes. And then we remove what's common. So here, the 2x squared and the 5x, I'm going to remove an x. Here, the minus 4x and the minus 10, I'm going to remove a minus 2. Here, the 2x squared and the minus 4x, I'm going to remove a 2x. And here, 5x and minus 10, I'm going to remove a positive 5. So my two factors in the denominator are 2x plus 5 and x minus 2. Now next, I have to state the non-permissible values. So the non-permissible values, just from the denominator, are that x cannot equal positive 2, or this factor would be 0. And the other factor I have to set equal to 0, so 2x plus 5 equals 0. I'm going to subtract the 5, and then divide out the 2. So that means that x cannot equal negative 5 over 2. So those are my two non-permissible values for the question. Now step 3, we divide out anything common. Again, it's very important that you do your non-permissible values first and then divide out anything common after. Because here I see that I have this common factor of x minus 2. So when I divide it out, it is eliminated because x minus 2 divided by x minus 2 is just 1. So your new equation, when it's all simplified, is just 3 over 2x plus 5. So that's fully simplified, but 2 is still a non-permissible value, even though we've canceled it out. All right, let's try the same steps with b. So here I have 1 minus t, which is already factored, and then on the bottom, t squared minus 1. So that's a difference of squares, which means when I factor it, I square root the fronts and put them in the fronts, I square root the backs and put them in the backs, and then I do different signs. So then let's take a look at our non-permissible values. So from the denominator, I see that t cannot equal 1 and t cannot equal negative 1, or you'd get 0 from those factors. Step 3 then is we're going to try to divide something out. But this one's a little different because it doesn't look like anything's the exact same. But I notice at the top, 1 minus t is kind of the opposite as the bottom t minus 1. So anytime you see that, it's the signs that are different because this is really a positive 1 and a minus t, whereas on the denominator, it's a positive t and a minus 1. So anytime you see something like that that's kind of backwards, you can divide out a negative from the top or factor out a negative. That makes the t positive and the 1 negative. So again, it switches things around, so now it looks exactly like that bottom factor. You can check that again by just putting that minus 1 back in, and you'd notice you get the exact same thing that you had before. So now I notice that the common factor is t minus 1, so I can divide that out, and I'm left with minus 1 over t plus 1 for the final simplified answer. And we're just going to finish this video off with a few textbook questions, so please try page 317, number 4, 6, 8, and 13, and make sure you let me know if you have any questions or need any help. Have a great day, you guys.